Hello everyone, I am Marwan Strouhal. Me and my teamwork, we have tried to study the effect of a rotating circular cylinder on a steady flow regime at various Reynolds number. Today I'm gonna show you the variance between our study and the recent findings and deliver a sufficient result that will help us to understand the effect of rotating cylinder on the fluid behavior and parameters quantities. Based on Flettner experiment who has tried to reduce fuel energy of a ship by generating a magnet effect around the surface rotating cylinder as means of propulsion. Several research studied the effect of rotating cylinders, but in different domains. Applications include electrical motors, shafts, nuclear reactors, heat exchangers, and etc. Now I'm gonna show you the plan of our presentations, which include introduction, methodology, fluid domain and meshing, results, conclusion. Experiments and numerical studies have been experienced the effect of rotating by Flettner rotors, which is the image set in the left hand side, was the experiment study who has built a ship which contains rotors and stands vertically up on its surface in order to generate a magnet effect to drive ship forwards. Several numerical studies have been experienced with the use of the dimensionless rotation parameter. In methodology, we have tried to use the momentum equation and the conservation of mass in case of studied the behavior of the fluid flow around an obstacle. Then we have used an average technique which will lead us to a turbulence modeling, and in our study we have used to work with the Kype model, and in this slide you can see the equations that represent the turbulence kinetic energy K and the dissipation rate of turbulence kinetic energy epsilon. In the fluid domains, we have work in a large computational domain, and the image in the left hand side shows the domain that we have worked on it, and we have the flow and the uniform fluid flow is starts from the outlet velocity and from left to the right in the outlet pressure, and we have used a zero pressure gradient at the outlet. So in the image in the right hand side represent the structured mesh near the surface cylinder and for the fluid domain. The objective of this numerical study is to examine the impact of rotating cylinder, and we have tried to vary the dimensionless diameter, which is the rotation rate parameter, from 0 to 5, and see how this dimensionless parameter impacts on the fluid behavior and stagnation point, and the fluid flow parameters left drag and Strouhal number. So, and in the figures in the next slide we will see figures which are represent the behavior of the fluid, the velocity vector, pressure vectors, pressure controls, velocity controls, and vorticity controls. So in this slide we can see the impact of alpha. Alpha is the rotation rate parameter on the variation of drag and left and Strouhal number, and we can see that as we increase the value of alpha, the value of left and Strouhal number decreases, but in contrary in the case of drag coefficient, where the values of drag reduces, then diminished in a value, in a high value, decrease in the high in the minimum value, and increase in the high value of alpha. Here the streamlines patterns, which shows us the variation of stagnation point from 0 theta into 90 as compared to the recent findings. Velocity control shows that the instabilities generated in case of high Reynolds numbers diminished as we increase the value of alpha. And images here classed from left to right, and where the first image in the left hand side represents alpha as in a stationary case, and the last image represents the value of alpha, where alpha equals 5. Also, pressure instability is generated in the wake and diminished as we increase alpha. Velocity controls diminished also where we increase alpha, and shows us that the vortex shadings decreases as we increase alpha, and the rotation ridge parameters helps us to express the instabilities that are generated around the cylinder. As a conclusion, the study of unsteady laminar and turbulent flow around a stationary and rotating cylinder was the main object of the present work. We compared our results with the previous literature for stationary and rotating cylinder cases. Vortex Kármán streets phenomena generated in the stationary cylinder case have not been impacted by small alpha values, but they have been expressed as high alpha values. Streamlines patterns changed with every increase of alpha, and they have reached steady patterns along with the downstream at alpha values. And thank you for